you all had a good weekend. Sounds like had some fun things happen this weekend. CJ was in a bull riding competition. Some guys went to the Jeff Dunham.
No, that was last year.
Was that last year? I thought you said it was last week.
No, you said it was last year.
Oh, my bad. How about you guys? You guys do anything fun this weekend?
Yes, we did.
Yeah? That's good. All right, well, you guys, I was bored, so we're going to go ahead and start the day. So what we have planned for you guys is we're going to do a quick video over kind of welding inspection. We're going to look at 4 pieces there, and then we're going to get into some weld discontinuities. And we're going to utilize a note-taking format for that as well. And so we'll go ahead and get started.
Make it several different welds, lap joints, clean joints, and put them all, and also some groove welds. Now we finished those welds, but how do we now determine where we need improvement at, and how do we determine where those welds are acceptable? There's a couple different criteria that we can use to look at the welds and determine where we need to improve at. There's a lot of different types of what we call non-destructive testing, where we can still test the part, but it can then still be put into service. One of the most common types of non-destructive testing is the visual inspection. So when we look at visual inspection, we're going to take a particular joint, and we'll use this T-joint here to start with, and we're going to look at it, and there's a couple different parts of the weld that we should be familiar with. On this particular weld, we've got a toe of our weld here, and a toe of our weld here. The part across the middle is what we refer to as the face of the weld. So when we look at this particular one and we want a flat face, you want that area from here to here to be relatively flat. The alternative would be to have a concave weld. Concave welds can be more susceptible to cracking than, say, a flat or even a convex weld, which would be slightly humped up in the middle. So we're looking for a flat face as the key. The other criteria that we're going to look at is proper placement in the joint. You know, obviously we want the weld to be in the joint. We don't want to be straying out of the joint. And I've got an example here of a lap joint, and we've got a fillet weld on here. And if you look right at the beginning, it's actually more on the bottom plate than the top plate. That's what we're referring to as proper placement. So you can see as we started the weld, we noticed we were on the bottom and then came back into the joint and proceeded down the weld. So again, making sure the weld is where you want it and is properly placed is also a key criteria to look for in your welds. The other one is what we call, you're looking for the weld to be fairly uniform. And by fairly uniform, we mean nice and straight, and also, you know, you don't have places where it's wide and narrow, wide and narrow. So for example, we built the pad earlier, or when you build a pad, the idea behind that is to get consistent with, number one, keeping a straight line, and number two, making sure that they're consistent in width as you proceed down the pad. So fairly uniform weld is also an important criteria to look for when welding. And one of the last ones that we look at is the wash-in, and we'll select this one here. This is a lap joint. But when we refer to wash-in, if we go back and we look at the toes of the weld that we talked about, we want the transition at the toe of the welds to blend in smoothly with the base material. What happens is if it doesn't transition smoothly or have good wash-in, you could possibly get a stress riser there. And one of the examples that we commonly use for a stress riser to simulate this would be if you take a piece of string and you pull on it, and it's hard to break. Well, if you go and you put a knot into it, like for a fishing line or something, and you then pull on it, you'll notice that that fishing line a lot of times will break right there where that stress riser was. Same thing in our weld here. We want it to transition smooth and have a nice wash-in with our base material in these particular areas at the toes. So as a summary, just to wrap up here what we've talked about, there's 4 general areas that we can focus on for visually inspecting a weld. One of them would be a flat face. One of them would be proper placement in the joint. The one that's fairly uniform, being the weld consistently shaped down the joint. And the last one is good washing at the toes of the weld. So if you're looking for any other information on welding, you can visit linkelectric.com.
Alright, you guys, so what was that 4 criteria for weld inspection? You guys take note of that?
Flat face.
So flat face, we make sure we want to have a flat face in our joint, no convex or concave joints or anything like that. What else, CJ? Did you get a second piece? Alright, so joint placement, we want to make sure that's even inside of our joint like that. And then thirdly, our uniform, we want to look at our travel speed, make sure we have a good solid bead all the way across our joint, no waves or anything like that. And finally, we want to make sure that we have a good wash in, all our toes are tied in smoothly through our base metal. And so, alright you guys, as you've noticed, I handed out a little note-taking format for you guys. And so, as you can see on the layout, on the left side, that's going to be the discontinuity we're going to talk about. And that's also going to be a couple of notes for the causes of these defects. And on the right side, of course, that's going to be how we're going to correct them. And so the first one that we see here is porosity. And this is pretty common in your GMAW welding. And you guys know the reasons on how we can get porosity.
Not proper gas, though.
Alright, so not proper shielding gas. And then also in addition to that, unclean base metal. So if we have like rust and dirt on our metal and everything like that, those gas bubbles are going to come up through our metal, through our molten pool, and they're going to just bubble up on us and create weaknesses in our joint. So as you guys can see here, this is an example of porosity. So it really alters the strengths of our welds. We want to avoid it every way we can. Okay? So, yeah, make sure for the causes that we have down gas bubbles trapped in the cooling metal, contaminants in our base metal. And then secondly, is porosity possible for shielded metal arc welding, you guys? You ever seen that before? Not really? Okay. Well, it is possible because in the sense that if we start weaving, so some of you guys have been using manipulation of some kind, whether it's zigzags or U's or whatever the case may be, if we start weaving too far, the rule of thumb is about 2.5 times the diameter of the electrode. The flux on that electrode is incapable of covering such a wide area, and so it's going to be unprotected essentially. And so it's going to start giving you porosity. And so always make sure to concentrate that weave so you can get proper shielding gas and good strong weld. So secondly, we're going to look at undercut. And so this is pretty common among first-year welders, and it's okay, we'll fix it. But basically, what happens here is the arc force will dig into your plate, depending on the joint. So for this T, for example, it's all about our work angles. And so if we come in here at a very steep angle, that arc force is just going to sit there and dig out on this top plate, creating a crater all the way along this piece. And the way that we fix this is by reducing our travel speed, or in addition to that, really focusing on our manipulations of our weaves. So, like we just talked about, whatever type of manipulation works best for you. In order to remove undercut, we want to hold on the outsides of our manipulations. And the reason for that is it's going to give that electrode a chance to fill in those craters, so we'll get rid of undercut entirely. So for corrections, make sure to have down proper manipulation, possibly travel speed, and then proper work angle. So for T-joints, for example, that's a 90-degree angle, so we want to split that angle with a 45-degree to ensure that we're getting even deposits on both sides. What's that?
Not for the travel speed.
Proper manipulation. So the next piece we'll look at is incomplete fusion, and on your notes you'll see it's identified as cold lap. And so this is basically your weld metal's inability to fuse with your base metal. And so have you guys seen that before, to where you'll have a bead on your laps, T's, or butt joints where it kind of starts to curl under? See how we kind of start to get that curl and it's not actually fusing. So if we refer back to the video, it's not getting a proper tie-in.